Okay, it's me again, back for the other part of chapter 17. So this, I guess, we could also kind of label as our part 2 for this chapter. I already did a little short video on my notes for the differences between two proportions. So now we're going to discuss the difference between two means. So remember that before we used to compare a value from our sample to the mean from the population. But now, if we meet our conditions, so now if conditions are met, and we will discuss them later, if conditions are met, we can compare the means of two groups. And they don't even need to be the same size. Hello. They don't need to be the same size. So I want to make sure everybody's clear on that. Okay, so the two groups could actually differ in size, and in the packet, the packet examples, they do differ in size. Okay, so I want to discuss this as a two-sample t-test, because remember, in this class, when we're testing means, several pieces of information are usually missing, so a lot of times we do not know the standard deviation from the population for the population of interest. And then most of the time when we look at sample data, it's actually very tiny samples. So we're forced to use the t-statistic. If you need to, you look back at the learning materials from chapter 14, which discuss more in depth the t-distribution, both the materials provided by the coordinator as well as my own videos. So this is referred to as the difference of two means. So I just want to make sure that we're clear on the information that we're going to actually be given here. So just like before, when we had a t-test, we could be given data or statistics. I'll refer to that later when we talk about what we're doing in the calculator. But I want to give you a few notes. Like the first sample mean is going to be referred to as X bar 1. So this is a sample mean from group 1. And then they're also going to have their own standard deviation and sample size. Okay, that's supposed to be a 1, so let's not make it look like a comma. Then we're also going to get an X2 bar, which is going to be the sample mean from group 2. And then we're going to get an S2 and an N2. I'm sorry about my slides moving. I'm not very good at this app. Someday I might learn. If we have all this information and we've met those conditions, then we can enter this information into the calculator and proceed with the test. But again, I want to discuss what a confidence interval will look like in this case. And that would be a 2-sample t-interval, right? That's what it's going to be in the calculator. And it actually looks like this. We begin by taking the difference between our sample means, and then we add and subtract the margin of error. So, again, let's make our notes, right? If 0 is inside the interval, because we're talking about differences here, then we cannot, let's separate those words, we cannot claim the two groups are different. So the two group means are different. But if the entire interval is positive or negative, right? So the lower bound and upper bound are both positive, or the lower bound and upper bound are both negative, then we can tell one group had a larger sample statistic. And remember that this is true when comparing any groups, not just, I'm trying to write here and it won't let me. Right, there we go. When comparing any two groups, not just two means. This is also true when comparing two proportions. So I'm going to jump to another slide because I want to talk about how this works in the calculator for both stats and data. And then I'll talk about those three conditions we have to meet. So if we're going to run the hypothesis test, right, we're going to test our hypotheses. We're going to need to write out our null and alternative hypotheses in the proper form. So back in the test for proportions, we said that the two groups, let me reiterate, for proportions we said P1 equals P2 because we needed to know that the two groups were the same in proportion. So now we're going to say that the two groups have the same mean. And then, so the means for the groups are the same, right? That's what this means. Then we get to choose. Do we think that group 1 is maybe larger than group 2? Do we think that group 1 is maybe smaller than group 2? Or do we think maybe that they're just not the same and we're not quite sure about which direction that change is in? Then we go to our calculator and we run a 2-sample t-test, or we do an interval. And then we have this option again, data or stats. So we're going to put group 1 into list 1, group 2 into list 2, and choose greater than, less than, or not equal to, and run our test. It's that simple. If we have stats, however, we have a long list of things we have to enter into the calculator, which I'm going to write down. My dog is licking me while I make this video. Hi, Dexter. Okay, so I'm going to write this list down. X bar 1, S1, N1. So that's all the information from group 1. Then we need X bar 2, S2, N2. And then we also need to tell the calculator which direction our hypothesis is going to go in here so that we can have it correctly calculate our p-value and run our tests. And then our output is a t-score and a p-value. And to make our conclusion, you compare the p-value to the provided alpha level. And again, please go back to the previous chapter, chapter 16, to look at the conclusion statements and some help with that. I'll start going back to it in the next chapter so I can write it all out, like reject the null and all that stuff. In my examples, I will always write a conclusion sentence. It is required to make sure this test is completed. All right, so now, final step is always to list those required conditions that we are often asked to check before running. And the first one is still independence randomization. So if they were randomly sampled, then the subjects are also independent. Instead of success failure, we look at the nearly normal condition. And remember that to do this, we actually used the central limit theorem, and that's all the way back in chapter 14, if you need a reminder. And the central limit theorem says that we need to check if N1 and N2 are both greater than or equal to 30. And if that's true, then assume normal. Or if it's if it's data, we would look at the histogram for both sets of data. Okay, for the third condition, it's the 10% condition. And we're going to check if N1 and N2 are less than 10% of their respective populations. Excuse me. So these are the conditions that we have to check if we were to need to run a 2-sample t-test or a 2-sample t-interval. Follow up with watching the video I have for the examples from this chapter.